Hello class, welcome to Algebra Concepts Lesson 3.3, which is all about linearity and continuity of graphs. By the end of this lesson, you should be able to determine whether functions are continuous, discrete, or neither, and determine whether functions are linear or nonlinear. So let's talk about some vocab. First, let's talk about the word discrete. So what discrete means is that you're going to have a bunch of points. Okay, so there are no actual lines on a discrete or as part of a discrete function. They are only ever points. Okay, so points that are not connected. And then in order to determine the domain, it would just be the x values of those points. And then to determine the range, it would be the y values of those points. Okay, so discrete functions are points that are not connected. The domain is the x values of the points. The range is the y value of the points. All right, so then let's move on to continuous function. So a continuous function are when all of those points are connected to form a line or a curve. Okay, so a continuous function can be a straight line or a curved line. The domain is going to be all real numbers. In case you're looking for a faster way to write that down, this R with like that double line right there, that stands for all real numbers. Okay, so that's a nice little shortcut to know. If you don't remember that and want to write all real numbers, totally fine. And then the range, so the y values would be one interval of real numbers. So the range for this graph, it looks like it goes down to like -5. So this range would be y is greater than or equal to -5 because it's everything above that -5. Okay, so that's what the range would look like. That's what it means by an interval of real numbers. All right, then neither discrete nor continuous. So this happens when you have both points and lines. Okay, so when it doesn't, it's not continuous through the whole thing, but there's also lines. Okay, and then the range or the domain varies. Like you can see, the domain would be everything less than -5 and everything greater than 5. So you would have x is less than or equal to -5 and x is, sorry, not and, you'd say or x is greater than or equal to 5. Okay, so you can see that that'll vary depending on where the space is in the graph. And then the range, again, it's at a -5, so you'd say y is less than -5, less than or equal to -5, and y is greater than or equal to -5. All right, so that's what we're looking at today. Discrete, continuous, and then neither discrete nor continuous. So if we look at this problem, we have the Bargain Book Barn sells young adult novels on a sliding scale. That is, for the more books you buy, the cheaper they are. The f of x model that the stores, let f of x model the store's prices for given quantities. Is f of x discrete or continuous? Explain your reasoning. So looking at this graph, tell me, is this discrete or is it continuous? Well, it only has points, so that means it is discrete. And the reasoning is there are only points. Okay, then the next part of the question, move that for a second, list the domain and the range. Okay, so the domain, like I said earlier, is going to be your x values. So it's nice that we have this table right here because x is going to be our number of books. So 1, 2, 3, 4, 5. And remember, you use the squiggly brackets. And then for the range, we have our price. So 150, 290, 430, 570, and 710. So that's our domain, that's our range, and it's discrete. So that's kind of the type of problems for the first half of your assignment is going to be determining whether it's discrete or continuous or neither, and then sometimes listing the domain and range. All right, then let's look at this next graph. We have determine whether f of x and g of x are continuous, discrete, or neither. Explain your reasoning. So you can see here f of x, I have a nice line. It's curved a couple times, but there aren't any spaces in it. So this would be a continuous graph. And the reason being it is a continuous line. There are no breaks in the line. All right, g of x, if we look here, I have a line segment here, a dot here, a line segment here. Okay, so when you see both lines endpoints, this is an example of neither. Okay, so it's neither because it has continuous sections and discrete sections. All right, and moving on to the next thing. All right, so this is a question for you. I want you to determine which functions are continuous. Select all that apply. There may be one, there may be two, there may be three. Maybe there's four. I don't know. You tell me how many of these are continuous. Good luck. All right. Hopefully you said B was continuous and D was continuous. All right. They both have those lines that just keep going. All right. If you have questions about that, please be sure to ask for some help. Moving on. All right. Apply discrete and continuous functions. As a private investigator, Tia charges $25 per hour for any amount of time up to 8 hours, and then a flat rate of $250 per day. Use the graph to determine if the function that models the situation is discrete, continuous, or neither. Okay, so let's take a look at this graph. We have a little segment right here, and then a bunch of dots. So what is it called when you have a little bit of a line and then a lot of dots? That is an example of neither. Okay. Okay, now it's your turn. Imani pays $30 per hour for any part of an hour for her weekly piano lessons. If this function is modeled by the graph, is the relationship discrete, continuous, or neither? Good luck. Hopefully you said this is continuous because it's just a line. There aren't any gaps in the line. All right, now we're moving on to the next idea, okay? So we've talked about discrete, continuous, and neither. Now we're going to talk about how to identify if something's linear or nonlinear. Okay, so some ways to tell if something's linear is a key thing is no exponents other than 1, okay? And often 1, it's an invisible exponent, okay? But if you have an exponent of 2, 3, 4, a negative number, okay, that means that it is non-linear, okay? So if it has an exponent other than 1, it's non-linear. All right, and then another thing, you can never divide by x. Okay, if you divide by x, it is non-linear. All right, so let's look at letter A. F of x equals 5x plus 10. So I have 5x. There's no exponent listed here, so we assume it's a 1 plus 10. So this would be an example of a linear function because we only have exponents that are 1 and we're not dividing by x. All right, letter B. G of x equals x squared plus 2x minus 8. I see an exponent that's not 1, so automatically I know this is nonlinear. All right, h of x equals 3x cubed. Okay, I see an exponent that's not a 1, so this is nonlinear. F of x equals 6 divided by x minus 9. Okay, I'm dividing by x, so this is non-linear. G of x equals 5. Okay, so there's no variable this time. So even though there's no variable, this is considered a linear graph because we don't have an exponent that's different than 1 for a variable, and we are not dividing by a variable, so it's linear. All right, h of x equals 7 minus x. Okay, so this time our variable is negative, but that doesn't matter, that doesn't change it. It still has an exponent of 1, so this is linear. All right. Now I want you to determine whether if the function listed below is linear or nonlinear. Good luck. Hopefully you said we're dividing by x and that makes it nonlinear. All right, let's look at functions in table form. So we have Selena kicks a soccer ball. The height of the ball after each half second is recorded in the table. Is the function that models the height of the ball a linear or nonlinear function? Okay, so there are a couple ways that we can do this. One of the ways is when you see that your x's are always changing by the same amount. Like we're told this table records after each half second. Okay, so we know that these are always changing by the same thing. In order to be linear, these also have to change by the same amount each time. Okay, so going from 2 to 28, that is adding 26. Going from 28 to 46, that is adding 18. So right there you can see these numbers don't match. And something to be careful of is you can only do this if you can only stop there if these numbers match. Okay, so these are changing by the same. That means these should change by the same. Since they're not, we assume this is non-linear. Okay, so if you have numbers that are changing by the same amount on one side but not the other, it's non-linear. Okay, another way that you can check is you take, let's see, it'd be 26 was our y over 0.5. Okay, and if you were to divide that, you'd get 52. And then if you do 18 over 0.5 and you divide that, you would get 36. So since those numbers don't match, you know this is nonlinear. And doing this method where you make kind of a fraction, that works best when these numbers are different. Okay, so like if this would have been going up by 0.5 and this would have been going up by 1, that is a good time to do this method. It's a little longer, but that's how you have to do it. All right, and then question 5, determine which table represents the linear function. All right, so I feel like I maybe didn't put enough examples in for this one, so I'm going to walk you through this one, and then that'll just be the end of the video, okay? So if we look at this, I'm going to look and see, okay, how did my x's change here? Going from -2 to -1, I added 1. Going from -1 to 0, I added 1. Going from 0 to 1, added 1. Going from 1 to 2, I added 1. Okay, so all of those numbers match. That means all of these numbers should match. If they don't match, that means that this is not linear. Okay, so going from 4 to 1, that is -3. Going from 1 to 0, that's -1. Okay, already these two numbers, they don't match. That means this is non-linear. Okay, and then over here we have going from -2 to a +1, that's adding 3. Going from 1 to 2, okay, this one's adding 1. Going from 2 to 5, that's adding 3. Going from 5 to 7, that's adding 2. Okay, so you can see this time they don't match. That means we have to do those fractions to compare. Okay, so going from 8 to -1, that's +9. All right, so then what I'm going to do is I'm going to say 9 over 3. Okay, so you take your change in y over your change in x. And then Going from a -1 to a -4, that is, oh, sorry, this should have been -9. I mixed up there. Let me backtrack. So it's -9. So it'd be a -9 over 3. So that equals -3. All right. Then going from -1 to -4, that's -3. So that's -3 over 1, which equals -3. So you can see these numbers match so far. So I have to keep checking. -4 to a -13, that's -9. Okay, so I have -9 over 3 again. So that's the same one right here. And then going from -13 to -19, that's -6. And then that's over a 2. -6 divided by 2 is a -3. So you can see all of these fractions end up simplifying down to the same number. And that means that this is linear. If you have any questions at all about that, please be sure to ask for some help. I'm more than happy to help you. I hope you have a great day.